Saxon Algebra 1, lesson 111. That's a lot of ones, you guys. This must be the number one lesson. It's more on the topic of conjunctions and disjunctions, which may leave your head feeling a bit foggy, but what we're doing here is graphing inequalities. That may leave your head a bit foggy. It's where we have the number line and we do stuff like this, right? Where we figure out where the solution lies and we draw circles or we color them in with dots sometimes and make Micah's brain go kooky. So we're doing more of that. We remember that, here's just a little intro reminder business. We remember that we have this three-part way of writing inequalities now. This is when we want two things to be true. We want x to be, I'm going to write it like this so it looks the same. We want x to be greater than 4. At the same time, we want x to be less than 14. So instead of writing it out this way, this is the shorthand version of what we're doing. This is called a conjunction. Right? Yes. Conjunction. Two ways to write it. We're going to make it just a little itty bit harder for ourselves. Just a little. Here we go. Ready? Here comes the explosion of ones. Lesson 111. So it's 111.1 is our first example. Graph minus 5. No, I'm not going to say it out loud. That's annoying. Whoops. 2. And then we always have a domain with these, which basically tells us how to graph it, right? Usually it's either the reals or the integers. I'll talk about that when we get to it a little bit more. I know this can be a confusing part of the problem. Okay, so the problem with this is when we go to look at our x, we see he's not by himself. He's not by himself. He's badgered by this minus 4. So we have to get rid of the minus 4. The way that we do that is to add 4. Right? That's going to cancel that out. Okay, that looks really good. The problem is that when we have equations, okay, I'm talking about equations first, we have to do whatever we do to one side, we have to do to both sides, right? So this is an inequality and there's actually 3 parts to it. So how do we know which part to add 4 to balance this out, right? We have to make it the same. Well, spoilers, we do it to all 3 sides, right? Identify your inequalities. They're the dividing lines. So we have to add it to the far left, the far right, and the middle. That keeps it in balance, okay? That's kind of fun, easy. Minus 1 is less than or equal to x is less than 2 plus 4 is 6. Okay, so now we've got this all cleaned up because our little x guy is by himself. Domain equals the integers. That means integers are like minus 2, minus 1, 0, 1, 2. It's the whole numbers. There's no fractions and decimal parts in between. So when we graph, we put dots on the numbers. So I'm going to go minus 2. I'll tell you why I chose that in just a minute. 0, 1, 2, 3, 4, 5, 6, 7. That had to get a little crowded, but that's okay. All right. Here's an equal sign. That means we want to include minus 1 in the solution. So I put a dot on minus 1. Then I go up to 0. Well, I'm going to keep going like this, right? But let's see where the ending is. 6 is, it's got to be less than 6, and 6 is not part of the solution. So that means 5 is the greatest number in our solution set. And then I just backfill to get the rest, okay? There is our solution. And is it right? From minus 1 to 5. Yay, that's right. That's not so bad, is it? It's kind of fun. Now, disjunctions I'm not going to do a preamble on. Remember that the key word with conjunctions is and. There, we saw it there. And this presentation in itself says and because it combines the two things. In disjunctions, the magic word is or. So here's what we're trying to graph. Sorry, I was busy looking at the book. X is greater than or equal to 3, or X is less than or equal to -2. Domain equals the integers. Here's my short-handed way of writing that because, you know, life is short. I don't need to write forever. Now with this one, there's no work we have to do to clean it up because this is already set up just the way we want it. And what was I going to say? Oh, we can't smush these together into a single statement like that. These we have to just do differently. Remember that with conjunctions, we're looking for the overlap in the solution. And with the ors, the disjunctions, as long as our solution satisfies either one of those, we're happy. So we want it to be greater than 3, less than -2. So here's what I'm going to do. -4, -3, -2. On the scales of these, just put enough so that there are an extra space or two on either end of your solution. So you kind of have to figure out the answer before you set the scale of it. It doesn't have to be even and perfectly representative. Like here, mine got a little crowded. Here, they're more spaced out. That's okay. Don't worry about that. You don't have to make it go to, you know, +20 and -20 every time. Just draw enough of the number line so that you can show your answer clearly, right? And showing the empty spaces is a part of showing the answer. So make sure there's an empty space or two on either end. Now for this one, we want X is greater than or equal to 3. Again, we're only graphing integers, so we don't want all the little things in between. 3 is part of the solution, 4, 5. Now integers are really frustrating because there's no way to show that it keeps going, that the solution keeps going, picking up every integer out here to infinity. We just have to live with the imprecision of that. I know, it's a little annoying because it's hard to communicate exactly what you're trying to say, but that's the way it works. So we've graphed this part here, and then this part, X is less than or equal to -2. We start at -2, and then we go to the less than side. Okay, it worked out this time perfectly. I didn't plan it so that it would be 3 and 3, but that's really nice, right? That lends a very clear picture of what we're trying to do. Okay, one more. Example 111.3, this is the last one of the lesson. X is greater than 15, or X is less than or equal to 10. These numbers are kind of big. That's a little weird. Domain equals the reals. Okay, we remind ourselves the reals, whoops, that's what I want. The reals means all the little bits in between, all the little fractions and decimals and everything else. So we need a different presentation style, not the dots, right? Okay, so here's my thing. I'm just checking to make sure that I copied the inequalities correctly, that this one is really just the greater than, and this one is the less than and equal to. I got it right. Okay, so I know that my smaller numbers are going to go from 10. These are actually way easy. When you graph the reals, it's way easier to get it right, because here's what I'm going to do. I'm just going to put in 10 and 15, greater than 15. So I circle the 15 to show that I don't include that, and draw an arrow saying, yep, everything that way. Less than 10, I color it in. I'm clicking that to include the -10. And then I'm taking everything less than. That's my final answer. I'm not even going to bother to fill in the other numbers in between or on either side, because with the reals, it's super clear that it's greater than 15, less than and equal to 10. Okay, and yay. Is this the right answer? Yes. Yay, we got everything right. Oh, this is 2. I didn't do my satisfying boxing. Let me just double check. Because, you know, I'm wrong sometimes. I'm not a 5. I'm not a get every single question right exactly every single time. I often make a kooky little mistake along the way. That's part of being a human being. Okay, I'm done. I will see you in lesson 112. Goodbye.